Okay, hello and welcome back to the basic Python course. This is session 2 about variables and data types. So I want to make a brief recap from last week. In the first session, we saw a very introductory first program, and we learned that variable assignments are different from mathematical equations in a sense that variable assignments, not both of the sides are equal as in a mathematical equation, but that whatever is on the right-hand side is being worked out and then submitted into the variable name, which is on the left-hand side. We also saw some restrictions for variable names, namely that they shouldn't include spaces and they shouldn't start with numbers. Okay, so with that, we want to have a look at data types and to a little bit dive into the topic, please ask yourself this questions. Which data types do you know? This could be maybe based on uh, experience with other programming language or experience with scientific working in general. Which data types do you know? You can now briefly pause the video to answer this question for yourself, and then I will go on. Okay, so first of all, there are numbers, which we know from mathematics. Um, There can be whole numbers, such as 1, 2, 3. There can be broken numbers, such as 4.5. And then there are special mathematical constants like P and E, for example, which are usually also broken numbers. Then there are what could be referred to as words or sequence of characters. So single words such as tree or house, or also entire sentences, such as this is a sentence. This data type in programming is usually known as a string, and we will have a look at this in a few minutes. Then there are logical states. So a statement can either be true or false, with true corresponding to logical 1 and false corresponding to logical 0. Then there are vectors and matrices, and vectors and matrices are typically collections of numbers arranged in some way. In some programming languages, vectors and matrices can also be collections of other data types. And there are many more. So to summarize our considerations about numbers and strings, ask yourself this question. What is the difference between the sequence of characters 23.50 and the real number 23.5? Well, there are certain things that we can say about one of them, but cannot say about the other one. So if we are, for example, looking at the string, we can say that it consists of 5 characters, 23.50. We cannot say this about the number because it's not a sequence of characters. And when it comes to the number, we can say, for example, that it has 3 significant digits, that it's smaller than 30, or that this number plus 2 is 25.5, which are all things that we could not say about the string, because the string, which is the first one here, is just a sequence of characters. Okay, so to start, I want you to enter the following commands into your console. I'm switching to my Spider IDE now, and I've here listed 5 variable assignments on the left, which I want you to enter into the console, because we will later need them in this session. And I will also do that right now. Okay, the first data type which we want to have a look at is strings. And we already met strings in the first session. So when, for example, I store my name as a string and then type print my name, then we know that the printing command is taking what this variable name contains and writes it onto the console. This is different from enclosing things inside the print function into quotation marks. In this case, we are not referring to the variable my name, but we are referring to a string. So the use of the single quotation marks signifies that we are constructing a string which consists of the words my name. And in this case, it will obviously not print my name, but it will print the string my name. So this is the difference between encircling and not encircling something with quotation marks. If you're not doing this, you're referring to a variable which possibly exists under this name. If you do it, you're referring to the strings, and everything that's inside the quotation marks is treated as it is. If we are unsure about what data type a certain variable belongs to, we can use the built-in function type together with the variable name to find out what the type of the variable is. So for this string variable, it returns str or str, which is just an abbreviation for string. Python is fairly strict about what operations we can perform with variables of a certain type. So if, for example, I take the house number that we created in the beginning and add 1 to this will give us an error. This gives us an error because the house number here is defined as a string, as you can see from the use of single quotation marks. So adding a 1 to this doesn't work. So in other words, this command gives us an error because we're combining a string with an integer. And Python has no way of doing this and therefore rejects our attempt. However, it turns out that Python is also quite flexible with the operators. If you are using variables of the same data type. So, for example, let's first have a look at another example. So, if we multiply the height, which is in fact a number, with 2, then we get 3.52, which is exactly 2 times the height. So if we type the name, which we have defined above, times 3, we would expect Python to reject this command, like here above, because we are combining a string with a number, but Python does not reject this command and instead executes it. And this is because Python understands this command to mean the following. Name times 3 is internally the same as name plus name plus name. And this is an operation which only combines strings. So as we have seen in the introductory first session, we can use the plus sign to chain strings together or to concatenate them. So name as a string times 3 would mean name plus name plus name. And this obviously has a meaning because it means to concatenate this string 3 times with itself. Similarly, if we enter house number times 10, this does not give us as a result the number 2210, but it concatenates the house number 10 times. Why? Because the house number was defined as a string, and using the multiplication and the plus sign on strings means something else than using it on numbers. If we here in this case would want to achieve the desired result, we would have to hit house number plus 0, which is the result of multiplying it with 10, and then encircling the 0 in quotation marks to indicate it is a string, because otherwise we would get the same error as here. Okay, next we need to have a look at two concepts which are called assignment and immutability. So we have already seen that if we are assigning something to a variable name, then we tell the computer to store this value, whatever we have written on the left, behind this variable name. This is called an assignment. And by default, most variables in Python are immutable, so they cannot be changed. This means, with respect to the house number here, that, for example, we can't take this house number and change the first character to, let's say, 3. This gives us an error because this string is immutable. It can only be changed if we overwrite it, or if we write something else into this variable name. So, for example, if we would want to add a B to that house number, often house numbers use A, B, C, and so on, then we get a result for this, but the value of the house number is unchanged. So the only way to change the house number to actually end on B is to take that assignment, is to take that command and assign it back into the variable name. And in that case, we would have actually changed the variable. So this is the meaning of immutability. Most data types in Python are immutable, such as strings and numerical types, as we'll see in a minute. We will, at the end of the session, also meet one data type which is mutable, that is, which can be changed without reassigning it into the variable name. Okay, so this is to keep in mind when you, for example, run commands such as h+1. You should then be aware that the original h hasn't changed. What you can do either is to write something like this. So calculate h+1 and then write this back into the variable h. And this again indicates the difference between variable assignments and mathematical equations. So there is no real number which satisfies the equation x equal to x+1. This is not true for any real number. However, as a variable assignment, it's fine because it doesn't mean that x is equal to x plus 1. It means that take what's given on the right-hand side of the equation sign, work that out, calculate it, and then write the resulting value into what's on the left-hand side of the equation sign. This also implies that when writing variable assignments, you may not have something else than just the variable of the variables into which you want to write on the left-hand side. For example, this would not be a legitimate variable assignment. Of course, you can always also just create new variable names. So in this particular case, for example, we can say that the age next year is equal to age plus 1. And then if we print age, it's left unchanged. And if we print age next year, it has the new value. Okay, so with that, we are already at numbers or numerical variables. And Python, broadly speaking, knows two types of um, numerical variables, which we have also talked about in our introduction. So the type of age, which is a whole number, is int, which is short for integer. So an integer is a positive or negative whole number. Which, so to speak, does not have a decimal extension. And height is a float. Float is short for floating point number. I think in German this is being referred to as Gleitkommazahlen. So this is the data format in which Python and many other programming languages store real numbers. Note that even if the number which we enter as a variable is a whole number, but we have used a decimal point in it, then even then Python will consider it a float. So this also means that whenever you use the decimal point, you will create a floating point number. Please be also aware that you shouldn't use comma for creating floating point numbers. So, for example, if we type this, the result of this will not be a floating point number, but it will be a tuple, which is a data type that we will see later on. Okay. So please always use point as the decimal separator. This is very common in the English language and therefore also most common in most programming languages. So when combining integers and floats, Python is very tolerant, meaning that you can generally combine integers and floats without any problems and without this giving an error, but the result would typically be a float. So for example, if the age of a child is 6, but the child says, I'm not 6, I'm 6 3/4 years old, then the type of child age would be int because it is an integer, but the type of precise child age would be float because it's not a whole number anymore. Okay, so as I already said, the result of a mathematical operation expression containing ints and floats will typically be a float. This is only not the case when all components of the calculation are integers. As in this case, and if a calculation of two integers gives a float, then also the result of that will be a floating point number. In fact, any calculation involving division will result in a float, even if the result of the calculation is in fact a whole number or an integer. If you are dividing integers and want to insist that the result should be an integer, then you can use the double slash, which is the so-called floor division and only gives you the integer part of the result for this division. So the result of this division would be 5.2, and this means that the answer here is 5. And it's stored as an integer. Okay. We can combine between data types. So we can, for example, combine between integers and strings, or floats and strings. And combining is very easy because the conversion function is always named after the data type. So string or str converts to string, and int converts to integers, and float would convert to floating point number. So here's an example. If the number of the beast is stored as a string 666, then like our house number above, then we could calculate the house number of the neighbor of the beast by converting this to integer and adding 1. So this would be 667. Now stored as an integer, not as a string. So here's another example. If the number of the beast is instead stored as a number, 666, then the neighbor of the beast, if they are living in 666b, could have this house number. That is, we are converting the number to string, and then we concatenate it with the letter B also as a string, as indicated by the quotation marks. And this also works. So please remember that variables are usually immutable. So if our commands would instead be like this, then this second line here has no influence on the value of number of the beast. So number of the beast remains an integer, and it's not converted to string by this line. So this command would fail. So here is how you would have to fix this problem. Once the number is defined, you would have to submit this string conversion back into the variable name. In this case, you are overriding it and it becomes a string. And then this command or this variable assignment would work because now number of beats is not an integer anymore, but it has been converted to a string. So with that, we get the correct and desired result. Okay, so let's return to user input, which we were using last week already in our little program, greeting the user. And let's this time ask for something upon which the user should enter a number. So we create an input prompt, how old are you? And then the user is requested to enter a number, say 51. And then we run the following command. Age next year is user age plus 1. This obviously fails because, and the reason that it fails is that the type of user input is always, no matter what the user is entering, a string. So Python here is playing it safe and always gives us the user input as a sequence of characters, even if it would be a string. Even if it would be an integer or a floating point number. So if we want to get numbers from the user, we must first convert the result of the input function like this. Once again, the query again, doing something, and then user age could be converted to integer. Remember to write that back to the variable. And then this command should work. And we get a sensible result. So I'm now opening the file age next year. And this program shows you these commands that I've just tried on the console, put back into the editor to write a little program. And we can have a look at this program to understand how things are working in Python. So in the beginning, it just does what we have already done. It gathers the input, converts it to integer, and calculates the age 1 year later. And then at the end, generates a little message consisting of the string in 1 year you will be, and the age next year converted to a string so that this string concatenation actually makes sense. I will try this program. And it works perfectly fine. Okay, so now let's do a few checks to more deeply understand this. Does it, for example, matter for the workings of the program whether we convert the user input to int or float? Let's try out. No, it does not matter in the sense that the program is still running, but now that we have converted the age or the user input to float, it's also being displayed as a float when being handled in this calculation and then converted back to string. So this is something you should be aware of. On the other hand, it now also allows us to enter broken numbers as our age. Okay, let's change this one back and do another test. So second, let's ask ourselves, what happens if we remove the string conversion function here. Obviously, the program doesn't work anymore. And this is because now age is an integer, which means that age next year is also an integer, which means that the thing which is here concatenated with the display string is also an integer. And we saw that we cannot combine strings and numbers using the plus sign. So let's revert this one and do another test. What happens if we leave it like this, not converting to float, and the user enters a non-whole number, such as 6.75? Then we also get an error because the integer conversion doesn't make sense, or the integer conversion fails in this case. One cannot convert the number 6.75 to an integer. One could, for example, convert it to a float and then round it to 7. In this case, it would be an integer. But in this simple form, it cannot be converted to integer. Okay, so with that, we want to have a look at our next topic, which is methods. So let me just clear my command window here. And then start with the next thing. So the next thing are methods. So in Python, if you want to know all the different kinds of operations that are applicable to a certain variable, you can do the following. You can type dir and then some variable. Let's, for example, take the name, which is still in our workspace. No, which is not anymore in our workspace. And run the command dir with name as an input argument. In this case, we get a very long list of things. And this list contains in the top very unintuitively looking things, starting with 2 underscores and ending on 2 underscores. Please ignore them for now. And then there are a few things which are still a bit unintuitive, but maybe make a bit more sense because they can be imagined to be operations performed on strings. For example, starts with or upper. So here's an example. Take the name of the string, which in this case is name, then write a dot, and some method from this list of methods, which we have just generated by typing dir and the variable name. We choose upper now, and then 2 brackets or parentheses. So if we run this, you see that this function upper has taken the variable name, which is a string, and uppercased all the characters in the string if possible. So there's no uppercase for space, obviously, but all the other letters have been turned to uppercase. Please note that this function doesn't take any input arguments because there's nothing it has to know in order to perform this operation except then the string, which is already given by its variable name. So if we would make this mistake, we would get the following error message. Upper takes no arguments, and we were giving one input argument to this function. And please also remember that strings are immutable. That is, even if we run this command, the name will still be in lowercase. In order to change that, we would have to submit it back into the variable name. In this case, the uppercase variable name would be stored under the original name of the variable. There are methods which require additional input arguments. And one example for this is the method count. So for example, I type name.count and then E as a single character. So this counts the occurrences of the letter E in the string name, which is Elon Reef Musk. And you could now expect that the result is 4 because the string in total contains 4 E's, but the result is 3. And this is because strings are always case sensitive in Python. So lowercase and uppercase letters are treated differently, meaning that this string contains 1 uppercase E and 3 lowercase e. So this also means, for example, that the street name Fifth Avenue does not contain an A as a lowercase letter, but only 1 uppercase A. Interestingly, the Python syntax allows us to combine or chain methods and apply them in just one go. For example, you could take the main name, lowercase it, and then count the occurrences of the letter E. And in this case, the result would indeed be 4, because the result of name lower is this. And then if we are applying count E to this string, we indeed find 4 lowercase letters E in the string. Another example for this is that if you have an input query which asks a yes/no question, that not all users might enter the answer as intended. So, for example, you just want to have yes or no in lowercase letters, but some users may write yes capital letters with a capital letter in the front, or put exclamation marks, or maybe write everything in capital letters. And as we have seen, strings are case sensitive, so these would be different strings, or they might put a lot of spaces and very unsystematic lower in capital letters and spaces behind, and so on. And one way to solve this, so in this case, the answer is space, 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 Y capital E S space, 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 space. And this is obviously not equal or not identical to the string which just contains yes as three lowercase letters. So what you can then do is use the function strip, sorry, the method strip on the string, which first removes all the spaces at the beginning and the end, and then lowercase everything, which takes the result of this first operation and then puts all letters into lowercase if possible. And the result of this would be an ordinary yes, which you would expect as an answer to your user input. So this is another example of chaining operations or combining methods. Okay, so here on this slide, there's a list of the most important string methods, I would say. And you can, if you want, now pause the video for a moment and just play around with them and try to find out what they mean. I just want to direct your attention to another method for strings, which is called format. And here's an example for this method in action. So let's say we define the following string message: user curly brackets is curly brackets years old and curly brackets meters tall. Then if we print this string, we exactly get it like we have written it down. But the curly brackets in this string act as placeholders. So they can be filled with information using the string message format. So we type message dot format, and then we have three places to fill with information. Therefore, we have to enter three pieces of information or three variables. And we're gonna enter name, age, and height. So the result of this string operation will be another string, which is the same as this, but has the curly brackets filled with the information that we have given here as input arguments to the function format. Okay, so this is it for strings by now. Um, as a last piece of information, let me just tell you that you can even apply this to freshly generated strings. So I can, for example, enter the string and then after the closing quotation mark, immediately put dot format and then the same input arguments, and then create a message, and it would look the same. Okay, so with that, we're coming to other data types. And the question is, what other data types, so other than numbers and words or sequence of characters, can you imagine? So first of all, there are Boolean variables, which we have earlier in this lecture referred to as logical states. Take, for example, the name. It's still there. And ask whether the name starts with E. And this command gives us a result. So let's print the answer. It's false and ask for the type of answer. It's bool. So bool is short for Boolean, and Boolean is a logical variable which can only take two values, true or false. If you expected a true here on this example, remember that strings are case sensitive. So the name does not actually start with non-capital E, but we could, of course, make that true if we here enter a capital E, and then the answer would be true, and the type would still be a Boolean variable. This will later become important when we look at conditions and see how we can bring branching structure in our program. Okay, so sometimes the values of a variable should be left unspecified, or you want to refer to something as non-existent. So in this case, you can use the keyword none. And this basically means that you intend to leave the value of this variable as unspecified, and the empty data type available in Python for this is the none type. So if we now ask for the type of this variable, we get that it is none type. Another interesting occurrence of the none type is that functions that do not give output values also return the none type. So for example, if we print hello world, we know that this puts the words hello world to the console and then jumps to a new line. If we submit the output of this function to x, whatever x is, then x will also be of the none type. So simply consider this to be something like an empty information or an empty data type. Okay, then there are tuples, which we have already met in the beginning. Tuples are created by putting normal parentheses and then separating things inside the tuple with commas. And we accidentally created a tuple in the beginning by saying that the grade of someone is 1,3. So this was not actually a floating point number, but a tuple. And this is also a tuple. And tuples are basically multiple values in a sequence. That is, a tuple always contains more than one value, and the elements in this tuple are in order. The fact that the elements are in order means that we can refer to them using indices. Please be aware that the Python numbering system for sequences begins at 0. So the index 0 is referring to the first element, and the index 1 is referring to the second element, and so on. We will see more about this next week, so that the elements of this tuple would be indexed like this. Tuples, like strings, are immutable, which means that we cannot change their values. So if we, for example, wanted to replace bacon by organic vegan bacon, this would give us an error because tuples do not support item assignment, so we cannot change their values without overriding them. So in other words, in order to change the second entry, we would have to put organic vegan bacon here, and then we would have actually changed the value of the tuple. Okay, so not being able to change individual values in the tuple seems like an unnecessary restriction. And for this reason, there's another data type in Python, which is equivalent to a tuple, but mutable. So it allows for values being changed. This data type is being called the list. And lists are created in a similar way to tuples. So let's call this shopping list. Instead of using round parentheses, we're here using square brackets. And then enter the same information. So if we ask for the type of this variable, this would now be a list. A list can also combine different data types in a single variable. So you can also create a list consisting of strings and integers and floats, for example. And the great advantage of lists is that Python allows us to change individual values. So other than for the tuple, where such a command was not working, if we here replace the second item, remember that Python starts counting at 0, so the second item is referred to using the index 1. Then if we print the result of this operation, we see that the second entry has actually changed. Similarly, we can also apply methods to the list, which immediately change the list. So for example, for methods, there exists, for lists, there exists the method append. So we write the name of our list dot append. And what we want to append is sausages, so that we also have sausages on our shopping list. If we now print the shopping list, we see that it has extended and got another entry. And observe that this has happened without us having to write this new value back into the variable name shopping list. This command, the application of append to the shopping list, has immediately changed the shopping list. So this means that you should never use a command like this. Shopping list equal to shopping list dot append. So if we would want to append more sausages to the shopping list, please don't append to lists like this. Why not? Well, as I just said, this command already changes the list variable because lists are mutable data types. It's a mutable data type in Python, so the values of the list can be changed without reassigning it back into the variable. And then with this, append is a function without a return value. So it doesn't return the new list. It has immediately changed the list. This means that if we now print the shopping list, it has gone. It's none because the output of this function is none because it doesn't have an output value. So to repeat this, if you have the shopping list, appending to this list is already achieved by just writing down the name of the list and then dot append. And if we would want to correctly repeat the operation that we just tried, we have to do it like this. And in this case, the lists would still be there. Okay, so to sum up, you can understand a list as being equivalent to a tuple, so a sequence of ordered items with the difference that lists are mutable, so their values can be changed directly without having to override them. So to conclude this section, here's a list of methods that if you want, you can again work with and play around with a bit. And this would be the end of today's session on variables and data types. And once again, there are a few exercises. So here in the first exercise, you're not asked to write a little script as in the second one, but you are asked to predict what the result of certain commands will be. So when you solve this exercise, please copy those commands into a script and then add your predictions, what's going to happen, as comments into the script using the hashtag symbol. Then run the script and see whether your predictions were correct. If they were correct, fine. If they were not correct, try to find out what actually happened in these operations. In all these examples, yeah, something unexpected happens for some reason, which you can understand if you're rereading through these lecture notes, for example. Okay, so with that, I want to say thank you and hope you also enjoy the other videos from this playlist.